Hello friends, in today's session we are going to see some new topics related to exploring java.lang package chapter. Okay, so we will start with the class. Class encapsulates the runtime state of object or interface. Okay, objects of type classes are created automatically when classes are loaded. You cannot explicitly declare a class object. You obtain a class object by you calling the getClass method defined by object. Okay, so how you will access the class object using the getClass method defined by object class. Okay, so now class is a generic type that is declared class T. So you can declare a class of any type, any general type, and that T will be replaced by your class name at any time. Okay, T is the type of the class being represented or interface. Sampling of common use methods defined by class we will see now. Static class for name, string name throws class not found exception. Returns a class object given its complete name. Static class for name, string name, boolean how class loader throws class not found exception. Returns a class object given its complete name. Okay, so here for name, it when we are passing its class complete name, it will give a class object, and here also it will return a class object, but there are parameters difference. uh, Second parameter is boolean how. The object is loaded using class loader LDR. If the how is true, object is initialized, otherwise it is not. Okay, a extends annotation, a annotation class, a annotation type. Returns an annotation object that contains the annotation associated with the annotation type for the invoking object. Then annotation get annotations obtains all annotations associated with the invoking object and stores them in an array of annotation objects. Return a reference to this array. Class get classes return a class object for each of the public class and interfaces that are members of the invoking object. Then class loader get class loader returns a class loader object that loaded the class or interface used to instantiate the invoking object. Then constructor T get constructor class param types throws no such method exception or and security exception. Returns a constructor object that represents the constructor for the invoking object that has parameter types specified by the parameter types in bracket. Okay, constructor get constructors throws security exception. Obtains a constructor object for each public constructor of the invoking object and stores them in array. Returns the reference to this array. Sorry. Annotation get declared annotations obtains an annotation object for all the annotations that are declared by the invoking object and stores them in an array. Returns a reference to this array. Inherited annotations are ignored. Constructor get declared constructors throws security exception. Obtains a constructor object for each constructor declared by the invoking object and stores them in an array. Returns a reference to this array. Superclass constructors are ignored. Okay, so here they are giving only the declared constructors, and those are declared by the invoking object and stores them in an array. Superclass constructors are ignored in this case. Then field get declared field throws security exception, obtains a field object for each field declared by this class and stores them in an array. Returns a reference to this array. Inherited fields are ignored. Then method get declared methods throws security exception, obtains a method object for each method declared by this class or interface and stores them in an array. Returns a reference to this array. Inherited methods are ignored. Field get field string field name throws no such method exception and security exception. Returns a field object that represents the field specified by field name for the invoking object. Then field get fields throws security exception. Here we are getting only one field, and here we are getting the field array. Obtains a field object for each public field of the invoking object and stores them in an array, returns a reference to this array. Then class get interfaces. When invoked on an object, this method returns an array of the interfaces implemented by the class type of the object. When invoked on an interface, this method returns the array of interfaces extended by the interface. Okay, so there are two types. First is invoked on an object. When invoked on an object, what it returns? Array of the interfaces implemented by the class type of the object. And second, when invoked on an interface, it returns array of the interfaces extended by the interface. Then method, get method, string method name, class param types, throws no such method exception, security exception. Returns a method object that represents the method specified by method name and having the parameter type specified by param types. Then method, get method, throws security exception. Obtains a method object for each public method of the invoking object and stores them in an array, returns a reference to this array. Then string get name returns the complete name of the class or interface of the invoking object. Protection domain, get protection domain returns the protection domain associated with the invoking object. Then class super T, get superclass returns the superclass of the invoking object. The return value is null if the invoking object is of type object. Then boolean is interface returns true if the invoking object is an interface, otherwise it returns false. Then T new instance creates a new instance that is new object that is of the same type as the invoking object. This is equivalent to using new with the class default constructor. The new object is returned. Then string to string returns the string representation of the invoking object or interface. Okay. So here new instance will return the object that is same type as of the invoking object, and it throws two errors: illegal exception and instantiation exception. The methods defined by class are often useful in situations where runtime type information about an object is required. As table shows, methods are provided that allow you to determine additional information about a particular class, such as its public constructors, fields, and methods. Okay. When we have required runtime type information about class, these all methods are very much useful for us. And these methods that are provided that allow you to determine additional information about particular class, such as its public constructor, fields, and method. When we require the field array, or when we require the constructor array or class array, method array, in that case these methods are particularly useful. This is important for the Java Beans functionality, which is discussed in later sessions. The following program demonstrates the get class inherited from object and get superclass from class. Okay, so get class method and get superclass method we are going to discuss now. Now, in class Y, integer A, float B, two parameters. It is having class Y extends A, double C, one parameter. Then RTTI is a class name. X is instantiated over here, Y is instantiated, and we are having the class type object. Then class type object, x dot get class reference, and that class reference is stored in CL object. X is object of type CL object dot get name, and get class reference y dot get class CL object, and y is object of type CL object dot get name, and CL object dot get superclass, who is the superclass of this class, that is y superclass is x. Okay, so it will display it like this: x is object of type x, y is object of type y, and y is the superclass of y superclass is then class loader. The abstract class loader defines how classes are loaded. Your application can create subclasses that extend class loader implementing its method. Doing so, what we have to do is, you can create a subclasses that extend a class loader. You have to create a class extends class loader and implements its methods. And what now your class can do, it will define how classes are loaded. Doing so allow you to load classes in some way other than the way they are normally loaded by the Java runtime system. However, this is not something that you will normally need to do. Okay. Class loader will tell you how classes are loaded, or it will define how classes are loaded other than normally they are loaded. Okay, but normally it will not required by you, but still class loader has to do this. Now, math class contains all the floating point functions that are used for geometry and trigonometry, as well as several general purpose methods. Okay, so math is a super class, contains all predefined methods, inbuilt methods that are used for geometry and trigonometry, as well as several general purpose methods. Math defers to double constant E 2.72 and pi 3.14 that required generally. Okay, then transcendental functions. The following methods accept a double parameter for an angle in radians and return the result of the respective transcendental function. So these methods are nothing but sine, cos and tan that we have already seen in theory part of mathematics. Okay, mathematics in school, sine, cos and tan, as well as we have seen in mathematics of college. So these are already inbuilt functions. They will accept a double parameter for an angle in radians and return the result of the respective transcendental function. Static double sine double argument returns the sine of the angle specified by ARG in radians. Static double cos double argument returns the cosine of the angle specified by arc in radians. Static double tan double argument returns the tangent of the angle specified by arc in radians. Okay. The next methods take as a parameter the result of the transcendental function and return in radians that angle that will produce the result. Okay. Now we will see those methods takes as a parameter result of the transcendental function. Now here we have seen the sine, cos, tan method. Okay, so they will get double and double arguments respectively, and here in these methods, a sine, a cos, a tan 2, these methods will take the parameter your sine, cos, tan result and return in radians the angle that will produce that result. Okay, so which angle will produce that particular sine function result, that will be given. They are the inverse of the non-arc companions. Then static double a sine double argument returns the angle whose sine is specified by argument. Static double a cos double argument returns the angle whose cosine is specified by argument. Static double a tan double argument returns the angle whose tangent is specified by argument. Static double a tan 2 double x double y returns the angle whose tangent is x divided by y. Okay. The next methods compute the hyperbolic sine, cosine and tangent of an angle. Okay, sin h, cos h and tan h returns the hyperbolic sine of the angle specified by ARG, returns the hyperbolic cosine of the angle specified by ARG, returns the hyperbolic tangent of the angle specified by ARG. Exponential functions. Okay, cube root, static cube root double argument returns the cube root of the argument. Static double exp returns e to the argument. Exponentary, then expm1 returns e to the argument -1, and static double log double argument returns the natural algorithm of the argument. Okay, so now we will see some more exponential methods. Static double log 10 double argument returns the base 10 algorithm of the argument. Okay, why we are seeing all these functions in math and transcendental functions and all this stuff? Why we are seeing them? Because you must know these functions are already there. Okay, these functions are already defined in math class. So what you have to do, you have to just pass the parameters, you have to just call the functions, and if your Java applications is requiring this type of result, you can directly call them. Okay, so no need to define them again. Static double log 10 double argument returns the base 10 logarithm for argument. Static double log 1 p double argument returns the natural logarithm for argument minus 1. Static double power double y double x returns y raised to the x. For example, power 2.0, 3.0 returns 8.0. Then static double scalp double argument integer factor returns value into 2 factor added by Java EC6. Static float scalp a float argument int factor returns value into 2 factor added by Java EC6. Static double square root double argument returns the square root of the argument. Now we will see rounding functions. The math class defines several methods that provide various types of rounding operations. Okay, they are shown in table. Notice the two ULP methods at the end of the table. ULP stands for units in the last place. Okay, it indicates the number of units between the value and the next higher value. So how you will remember it? ULP stands for unit in the last place, that these functions available in the next table. Last two functions are there and they indicate the number of units between a value and the next higher value. It can be used to help assess the accuracy of the result. Okay. Then static int absolute int arc returns the absolute value of arc. Static long absolute long arc returns the absolute value of arc. Static float absolute float arc returns the absolute value of arc. Static double absolute double arc returns the absolute value of arc. Static double seal double arc returns the smallest whole number greater than or equal to arc. Static double floor returns the largest whole number less than or equal to arc. Static int max int x int y returns the maximum of xy. Static long max long x long y returns the maximum of x and y. Static float max float x float y returns the maximum of x and y. And static double max double x double y returns the maximum of x and y. Okay. Static int min int x int y returns the minimum of x and y. Static long min long x long y returns the minimum of x and y. Static float min float x float y returns the minimum of x and y. Static double minimum double x double y returns the minimum of x and y. Static double next after double argument double toward beginning with the value of argument returns the next value in the direction of toward. Okay, if argument is equal to toward, then toward is returned added by Java EC6. Okay, next after double argument double toward, what is the meaning of this function? This is a newly added function beginning with the value of arg that we are specifying as the first parameter returns the next value in direction of the toward. If argument is equal to toward, then toward is returned. Okay. Then static float next after float argument double toward beginning with the value of argument returns the next value in the direction of toward. If argument is equal to toward, then toward is returned added by Java EC6. Double next up double argument returns the next value in the positive direction from arg added by Java EC6. Static float next up float argument returns the next value in the positive direction from the arg added by Java EC6. Static double rint double arc returns the integer nearest in the value to arg. Okay. Static int round float arc returns the arc rounded up to the nearest int. Static long round double arc returns the long rounded up to nearest long. Static float up ULP. Okay. Float arc returns the ULP for ARG, and static double ULP double ARG returns the ULP for the ARG. Now, miscellaneous math methods. In addition to the methods we have seen, math defines several other methods which are shown here. Static double copy sign double arc double sign arc returns the arc with the same sign as that of sign arc added by Java EC6. Static float copy sign float sign arc returns arc with the same sign as that of sign arc added by Java EC6. Static int get exponent double arc returns the base 2 component used by the binary representation of arc added by Java EC6. Static int get exponent float arc returns the base 2 exponent used by the binary representation of ARG added by Java EC6. Then static double IEEE reminder double dividend double divisor returns the remainder of dividend divided by divisor. Static hypotenuse double side 1 double side 2 returns the length of the hypotenuse of the right angle triangle given the length of the two opposite sides. Okay, so for if you want to know the hypotenuse, you will use this method. Static hypotenuse double side 1 double side 2. Static double random returns the pseudo-random number between 0 and 1. Okay, this is the very famous method random. Okay, why this method? When this method is used, whenever in Java, in your Java applications, you are going to create games. Okay, if you are going to generate any random code or any random thing you want to generate, you can do it using this function. Okay, static float signum double arc determines sign of the value. It returns 0 if arg is 0, if arg is 1 if arg is greater than 0, and minus 1 is arg if arg is less than 0. Then static float signum float arc determines the sign of the value. It returns 0 if arg is 0, 1 if arg is greater than 0, and minus 1 if arg is less than 0. Then static double 2 degrees double angle converts radians to degrees. The angle passed to angle must be specified in radians. Okay, so whatever you are passing in the bracket, they should be in radian. Result in degrees, it return in double format. Okay, so what is static double 2 degrees double angle converts radians to degrees? So whatever you are passing in the bracket, they must be in the radians, and you will get the result in degrees. Static double 2 radians, here you should pass here degrees, must be specified in degrees, and radians will be written. The following program demonstrates 2 radian and 2 degrees. Okay, so here is a program. Class angles double theta 120.0. Theta degrees is math 2 radians theta radians. So how you are calling this function? Can you see this? Math dot 2 radians. Okay, theta is equal to 1.312. Okay, and theta radians is math dot 2 degrees theta degrees. 120 degrees is this much radians, and 1.312 radians is this much degrees. Okay, strict math. The strict math class defines a complete set of mathematical methods that parallel those in math. The difference is that strict math version is guaranteed to generate precisely identical results across all Java implementation, whereas methods in math are given more latitude in order to improve performance. Okay, so what is the difference between strict math functions and math functions? Strict math is guaranteed to generate precisely identical result across all Java implementation. Okay, so general results will be same while you are using strict mathematical methods, and when you are using the math methods, they are given more latitude every time to in order to improve performance. Compiler. The compiler class supports the creation of Java environments in which Java bytecode is compiled into executable code rather than interpreted. It is not for normal programming use. Okay, so you cannot use the compiler class directly, but for the sake of understanding, for the sake of knowledge, We have given this, the compiler class supports the creation of Java environments in which Java bytecode is compiled into executable code rather than interpreted. Thread, thread group, and runnable. The runnable interface and the thread and thread group classes support multi-threaded programming. So now we will see each of them. Runnable interface, thread and thread group. The runnable interface. The runnable interface must be implemented by any class that will initiate a separate thread for execution. We have already seen this much in multi-threaded programming. Okay. So why we are seeing this much? Again, because we are exploring it. We are going to its details. How much functions are already available to use. Runnable only defines one abstract method called run, which is the entry point for the thread. Void run. Threads that you create must implement this method if you are implementing the runnable interface. Okay. Thread creates a new thread for execution. It defines the following commonly used constructors. Thread, thread runnable thread object, thread runnable thread object, string thread name, thread string thread name, thread group object, runnable thread object, thread group object, runnable thread object, string thread name, and last one is thread group object, string thread name. Okay, so these are the commonly used constructor if you are going to instantiate the thread. Thread object is an instance of the class that implements the runnable interface and defines where execution of thread will begin. Name of the thread is specified by thread name. When a name is not specified, one is created by the Java virtual machine. Group object specifies the thread group to which the new thread will belong. Okay. When new thread is there, group object will specify the thread group to which the new thread will belong. When no thread group is specified, the new thread belongs to the same group as the parent thread. Then max priority, mean priority. Following constants are defined by thread: max priority, mean priority, and norm priority. This priority we have already seen, we have already understood in detail in multi-threaded programming. Those who have not completed that chapter, multi-threaded programming, please go there and please understand them. Those who have already learned it but not remembering it, go there and learn it again, remind it again. And those who have already learned it but not understood, feeling that they are not understood it properly, you can go there and learn it again. Okay, this multi-threaded programming chapter is already available in my Udemy class, Java in detail. Okay, learn Java to master. As expected, those constants specify the max, mean, and default thread priorities. The methods defined by thread are shown now. Early versions of Java, thread also included the methods stop, suspend, and resume. However, as explained in chapter 11, these were deprecated because they were inherently unstable. Also deprecated are count, stack, frames because it calls suspend, and destroy because it can cause deadlock. Okay. Count, stack, frames is deprecated methods, and because they call suspend, destroy because it can deadlock. There are stop, suspend, and resume methods. Those are deprecated, and why those are deprecated, that we have already discussed. Okay, now we will see some methods defined by thread. Static int active count returns the number of threads in the group to which the thread belongs. Final void check access causes the security manager to verify that the current thread can access or change the thread on which check access is called. Static thread current thread returns a thread object that encapsulates the thread that calls this method. Static void dump stack displays the call stack for the thread. Static int enumerates threads, puts copies of all thread objects in the current threads group into threads. The number of threads is written. The static map thread stack trace element get all stack traces returns a map that contains the stack traces for all active threads. In the map, each entry consists of a key, which is the thread object, and its value, which is an array of the stack trace element. Class loader get context class loader returns the class loader that is used to load classes and resources for this thread. Static thread uncaught exception handler get default uncaught exception handler returns the default uncaught exception handler. Long get ID returns the ID of the invoking thread. Final string get name returns the thread's name. Final int get priority returns the thread's priority setting. Stack trace element array gets stack trace returns an array containing the stack trace for the invoking thread. Okay. Thread dot state get state returns the invoking thread state. Final thread group get threads group returns the thread group object of which the invoking thread is a member. Thread dot uncaught exception handler and get uncaught exception handler returns the invoking thread's uncaught exception handler. Static boolean holds lock object returns true if the invoking thread owns the lock on object returns false otherwise. Okay. Void interrupts the thread. Static boolean is interrupted returns true if the currently executing thread has been scheduled for interruption, otherwise it will return false. Final boolean is alive returns true if the thread is still active, otherwise it will return false. Final boolean is daemon returns true if the thread is daemon thread, otherwise it returns false. Boolean is interrupted returns true if the thread is interrupted, otherwise it returns false. Final void join throws interrupted exception, waits until the thread terminates. Final void join long milliseconds, waits up to the specified number of milliseconds for the thread on which it is called to terminate. Final void join long milliseconds in nanoseconds throws interrupted exception, waits up to the specified number of milliseconds plus nanosecond for the thread on which it is called to terminate. Okay, so it is not a normal join. Normal join is just a join and opening closing parenthesis. But here, after which time it will it is given, that will be the waiting time for the thread. This much time long millisecond plus integer nanosecond, this much time it will wait. Void run begins the execution of thread. This is very important method. Okay, if you will not call this method, your thread execution will not start. Then void set context class loader CL sets the class loader that will be used by the invoking thread to CL. Final void set daemon boolean state flags the thread as a daemon thread. Static void set default uncaught exception handlers thread dot uncaught exception handler E sets the default uncaught exception handler to E. Final void set name string thread name sets the name of the thread to that specified by thread name. Final void set priority in priority sets the priority of the thread to that specified by the priority. Then void set uncaught exception handler thread dot get uncaught exception handler E sets the invoking thread's default uncaught exception handler to E. Static void slip long millisecond throws interrupted exception. This is also important method. We have already seen suspends the execution of the thread for the specified number of milliseconds. Okay. Before understanding join, why we have using join, we were understood the slip method. Static void slip long millisecond integer nanosecond throws interrupted exception. Suspends the execution of the thread for the specified number of milliseconds plus nanosecond. Void start starts the execution of the thread. String to string returns the string equivalent of the thread. Static void yield, the calling thread yields the CPU to the another thread. Okay. So this way we have seen some new topics related to java.lang package. Okay. In the next session we will see more interesting, more important functions that are already defined. We will explore them, we will learn them, we will understand them. Okay. And the most important part of this chapter I want to tell you again and again is the more you practice, more you will understand and more you will remember. Okay. Only reading and learning of this chapter is not important and is not sufficient too. If you want to by heart this, just do not by heart it. Just practice and practice and practice. After practicing, you will remember which method is taking which parameter and which method is returning what thing. Okay. So then you will not need to remember it. You will understand it properly. And also main important thing, you will understand how it is used in practical part. So it will be more helpful for you. Okay, so better way, go to start from the first session of this chapter. Read each and every function, what parameters it is taking, what is it is returning, where it is used, how it is used, and try to apply them in your simple small Java applications. Okay, so when you will go for interview, and when you will implement your own Java methods, your own Java applications, at that place you will understand these methods usage. Okay, so meet you in the next session for more interesting functions that are already defined. So meet you in the next session. Thank you so much.